In this video, you are going to learn an insight of bone matrix in general. So, let's get started. The bone matrix, also known as collagen matrix, is the main extracellular component of bones. Additionally, it has three different cell types: osteocytes, osteoblasts, and osteoclasts. The bone is nourished by osteoclasts, which are situated in the spaces, or lacunae, between the layers of the bone matrix. Osteoblasts are primarily located on the surface of bones, although they can also be found inside the actual bone matrix. They are in charge of creating the bone matrix and controlling how it is mineralized. Large multinucleated cells, called osteoclasts, are necessary for the removal of calcified bone matrix and enable the ongoing rebuilding of bones. There are two basic forms of bone morphologically. 1. The compact or cortical bone. The section of the bone closest to the bone's surface, that is dense, is known as the compact or cortical bone. 2. The cancellous or trabecular bone. The deeper part of bones, also known as the cancellous or trabecular bone. It has interconnecting cavities that link to one another. Microscopically, both trabecular and compact bones will be structured in two different forms: A. Layered or lamellar bone, B. Woven bone. The bone matrix in layered or lamellar bone is laid out in sheets. Only 20% of lamellar bone is found within the trabecular bone, while 80% of it is located within the compact bone. The collagen fibers are haphazardly organized in the more immature woven bone. This type of bone is primarily present in growing and developing bones, as well as bones that have recovered from fractures. Comparing the lengths of a long bone and a flat bone will help. The flat bone is a cross-section from the skull, and this long bone is a portion of the head of a long bone. The collagen is still present in the slides, even though both sections have been decalcified. To make it simpler, to slice the bone into tiny parts. The flat bone has compact bone on both of its outer flat surfaces, but the long bone has compact bone along the outside edge, because the denser compact bone is often found closer to the surface. Latin's translation of the word trabecular is little beam, which explains why the trabecular bone possesses tiny dot beam-like features, also known as spicules. A network of interconnected compartments that contain bone marrow is created when the spicules join forces. Another bone with both types of morphology is the vertebrae, although it only has a very thin outer coating of compact bone. The majority of the bone is made up of trabecular bone. Additionally, the bone marrow is still visible in the crevices created by the spicules. In this image, the osteoclast can be seen in this image, resting inside a resorption cavity. It is created on the surface of the bone matrix. The osteoclast's numerous nuclei can help distinguish it from other cells with a similar appearance, such as megakaryocytes, which only have a single multi-lobed nucleus. Let's examine more closely the Haversian system or osteons, the structural units of compact bones. A central canal, known as the Haversian canal, and concentric lamellae, or layers, with a diameter of between 100 and 250 micrometer, make up an osteon. As seen in this picture, this canal contains tiny blood arteries and nerves. A little blood artery and the remains of nerve fibers are also visible. Haversian lamellae are the concentric layers of mineralized bone matrix that extend outward from the canal. The cement line, a thin purple or basophilic line, runs along the edge of each osteon. The lacunae, which are white areas scattered throughout the osteon and contain osteocyte remains. Large cuboidal or spindle-shaped cells with a basophilic cytoplasm are osteoblasts. I'm hoping that this bone histology video will provide you guys further insight into this subject. For more videos like this, don't forget to click the like button and subscribe on our channel for more videos like this.